Hello, my little mathematicians. Today, we're going to work on solving for a missing piece of a ratio. Um, first of all, in this top section, we know that all three of these ratios are supposed to be equivalent. So what would that missing piece have to be in order for them to be equivalent? So how to do that is we know that ratios are equivalent if you can multiply the top and bottom by the same thing, or if you can divide the top and bottom by the same thing to get your other ratio. Okay, so let's use that logic to find for these missing pieces. So for the first one, always move towards the direction of your unknown. Okay, so towards that way. So going from 8 to 64, what do? Well, I multiplied the 8 times 8 to get 64. So since I multiplied the denominator by 8, I need to multiply the numerator by 8. And 5 times 8 is 40. So that means 40 64ths is equivalent to 5/8. Okay, so I found the missing piece. Now, technically, like even if 40 was worked beautifully to get you 60, you wouldn't necessarily want to use this ratio to get the missing piece in this ratio, because what if this one was wrong? So you always want to go back to the one where they gave you both the top and the bottom to help you figure out the missing piece of this one. Okay, and again, always move towards your unknown. So I'm going to go from the 8 to the unknown. So from the 5 to the 60. Well, to get from 5 to 60, what do? You would multiply it by 12. So that means I have to multiply the bottom by 12. And what's 8 times 12? Well, 8 times 12 is 96, making this missing piece 96. So 60 over 96 would be equivalent to 5/8 as well. And that's how you solve the missing pieces of ratios. So why don't you go ahead and do the same thing and try to solve these ones? Okay, pause the video, figure it out, and then unpause it and come back with us. Now that you're back with us, let's see how you did. Okay, so going again towards the unknown. So from the 5 to the 7, so I need to go same direction from the 7 to the 21, you multiplied by 3. So then 5 times 3 would give you 15. So that missing piece should have been 15. And then again, use this same one. Don't use this one. Use this ratio to help you find this missing piece of this ratio, because they gave me both the top and bottom. So you want to go from the 7 to the 105, so that then you can do 5 times something to give you this. Well, 7 times what is 105? Let's figure that out. 7 can't go into 1, but it can go into 10 once. Subtract, you get 3. Bring down the 5, and 7 goes into 35 5 times. So 7 times 15 is 105, which means I need to do the same thing on top. I need to multiply it by 15 as well. Well, 15 times 5 is 75. So that missing piece up top should be 75. Okay, last one. I always want to move towards the unknown. So I'm going to move in this direction. So what did you do to the 32 to get the 4? Well, you divided by 8. So I need to divide 72 by 8. And 72 divided by 8, sorry, this pen is dying. So let's redo that. Divided by 8 here. So 72 divided by 8 is what? It's 9. So that missing number should have been 9. So 4/9 is equivalent to 32/72. Now going in this direction, so from there to there, how do you go from 32 to 48? Oof, I can't. Okay, so I mean, you always want to try the one that gives you both the of the numerator and the denominator, but if it's not possible, then fine. Let's just hope that we're right with this one and try to go from 4/9 to this. Okay, so 4 times what is 48? 4 times 12. So then 9 times 12 is 108. So that means that missing piece, you should have gotten 108. Okay. Hopefully you did fairly well on those. We're going to use that same logic for some of the other problems later on. Okay. Now for these ones, I'm going to use the table up above to answer these questions. The first one says, write a ratio for how much Sean spent on games to the amount he spent on souvenirs. Okay, so I'm only going to be focusing on Sean. So that's the top line. Okay, so focusing on Sean, I want to write a ratio of games to souvenirs. And it matters the order that they say. So they want games first and souvenirs second. And they also want it just focusing on Sean. So games, Sean spent 8. And for souvenirs, Sean spent 12. Okay, so this is the ratio of games to souvenirs from Sean. And then whenever we write a ratio, we always typically want to write it in lowest terms. So if I can reduce it, let's reduce it. This one can reduce by 4. And 8 divided by 4 is 2, and 12 divided by 4 is 3. That can't reduce anymore, so there you go. You're done. The ratio of games to souvenirs for Sean was 2 to 3. And if you reduced it by 2, that's fine. You just would have had to reduce it twice, and you still would have gone to 2/3. Okay, now for the next one, they said if he, Sean, spent 24 on games, okay, so games, and let's have that be 24. How much will he spend on souvenirs? How much will he spend? We don't know. So let's have that be a variable. Okay, I'm going to use my ratio that I already know. Okay, I know that the ratio of games to souvenirs is in a 2 to 3 ratio, right? When games is 2, he spends $3 on souvenirs. So now that I have this, I can use that to help me figure out this. And I use that same logic we did up above. 2 times what gives me 24? 12. So then 3 times 12 gives me 36. So if he spent $24 on games, then he's going to spend $36 on souvenirs, following that same pattern that he tends to do. Okay. Now, just FYI, you know you're correct if you check yourselves using what's called cross products and you get the same number. So, for instance, if you have 24 over 36, we said, is equal to 2 over 3. If you do the cross products of 3 times 24 and set them equal to these cross products, so cross across from each other, and products means multiply those two numbers. If we get the same thing, we'll plug into your calculator. 3 times 24 is 72. And 2 times 36, plug that in. You also get 72. If your two cross products are equal, then you know that your two ratios are equal. Just FYI, cool way to check yourself. Okay. The next one says, write the ratio that Ryan spent on souvenirs to the money he spent on snacks. Okay, so this time we're going to focus on Ryan. Okay, so Ryan, and we want souvenirs first because it's important. If they want whatever they say first, that goes on top. And then whatever they say second, that goes on bottom. Okay, so the amount of money that Ryan, spent on souvenirs, souvenirs was 20. And the amount of money that Ryan spent on snacks was 10. So he's in a 20 to 10, or can we reduce that? Yeah, I see that 10 can go into both. And 20 divided by 10 is 2, and 10 divided by 10 is 1. So he's in a 2 to 1 ratio. He always spent double the amount on souvenirs that he does on snacks. Okay. So that's the ratio of souvenirs to snacks. Always try to do it in lowest terms if possible. But I can also use that then to figure out missing pieces, like the next piece, the next question that asked me. It says, if Ryan spent 12 on snacks, how much did he spend on souvenirs? Okay, so we're still in this souvenirs to snacks for Ryan ratio. And we now know that it's a 2 to 1 for Ryan. And they said, okay, snacks is on the bottom. So I'm going to put 12 on the bottom where snacks goes. And then how much did he spend on souvenirs? Well, we don't know. That's why they said how much. So I'm going to use a variable, and souvenirs was on top. So my unknown is on top. And now can I solve for that? Well, always go again towards your unknown. So towards your unknown, towards, that's the same direction. So 1 times what is 12? 12. So then 2 times 12 is 24. And remember, he always spent double the amount of money on souvenirs than he does on snacks. So that makes sense. He should have spent 24 on souvenirs if he spent $12 on snacks. And there you go. That's how you use ratios to help you solve for a missing piece. All right, my little mathematicians, you've got this.